I want to start looking at compound inequalities, writing them and graphing them. So first of all, what is a compound inequality? And that's going to be two or more inequalities that are working together. And really we have two kinds. The first kind is called an intersection. The big word that should come to mind when you're thinking about intersection is the word and, because we'll have two inequalities where both of them are true. The first inequality and the second inequality are true at the same time. As far as their graphs go, that means that their graphs are going to overlap. So what do I mean by all of that? Well, here's an example where we have -2 is less than x, which is less than or equal to 4. This is two separate inequalities working together. So the first inequality that we're talking about is -2 is less than x. The second inequality is that x is less than or equal to 4. We can treat each of them separately at first, and let's take a look at that. If we're looking at -2 is less than x, that means that x is greater than -2. If we were going to graph that, we would use a circle on -2 because it can't equal -2. And x's are, all of my values are going to be greater than -2, so bigger or off to the right. For x is less than or equal to 4, we would use a dot on 4, and all of my x's are going to be less than 4. Now, since this is an intersection, we want to know about all those numbers that are true for both inequalities at the same time. Those ones that are bigger than the -2 and also less than the 4. That's going to be only these ones that are in between. We would still use a circle on the -2 and a dot on the +4, but we would only graph the stuff that is in between, which means we wouldn't need these arrows out here and out here. We're only talking about that stuff that's in between, where those two arrows overlap. Let's write a couple of compound inequalities. In this first graph, I notice that I have dots on -15 and -8, and what's highlighted is what's in between them. So what we're looking at is really this overlapping region where the first part is that x is going to be greater than or equal to -15. And this part where x is less than or equal to -8. Now, we don't want all those numbers, we only want the overlap. Well, so what we do is we rearrange this first inequality by switching everything around. So -15 is less than or equal to x, and x is less than or equal to -8. Notice that when we write the intersection, the compound inequality that uses and, we have that x that's in the middle, the smaller numbers on the left, the larger numbers on the right, and our inequalities that we use are both less than. See that visually it looks like the x is in between these two numbers, and it is. Graphically it is as well. So let's try another one. When we have the 6 and the 10 and the 11 are our endpoints, and we're talking about all the x's are in between, we can let x be in between the 6 and the 11. And we're going to do that using less thans. Now we also have to consider, should those be less than or equal to's? And since we have circles on our endpoints, no, they're not equal to. So this would be our compound inequality. The second kind of compound inequality is called a union. And that's when one inequality or the other one is true. So that important word is or. Their graphs are going to point in opposite directions. So instead of overlapping each other, they're going to point in opposite directions. Let's take a look at this example where x is less than or equal to 1 or x is greater than 6. For x is less than or equal to 1, we would use a dot on 1, and we want all of our x's to be smaller than that, so our arrow would go off to the left. For x is greater than 6, we'd use a circle on 6 because it can't be equal to it. And we want all the numbers that are larger, so all of these numbers are off to the right. Notice there aren't any numbers that can be smaller than 1 and bigger than 6 at the same time. That's why our arrows are going to point in opposite directions, and they are not going to overlap. If we have the graph and we're writing the compound inequality for this first example where everything is smaller than the 5 or bigger than the 13, all we do is write each of them individually. On this left-hand arrow, like we said, x is less than 5. It's not going to be equal to because it's a circle on the 5, not the dot. The other arrow, x's are going to be larger than the 13. Also, circle, not a dot, so it's just strictly greater than. To make it a compound inequality, what we have to do is put the word or in between there. So in the second example, we have all of our x's are less than or equal to 2. It's or equal to because it's a dot. Or all of our x's are going to be greater than or equal to 10. Consider this word problem. We have a company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. We want to write and graph a compound inequality that describes how tall the action figure can be. Now there are a couple important phrases in this word problem. First of all, it says that the action figure must be at least 11.2 centimeters tall and at most 11.4 centimeters tall. Of course, those are our most important numbers, so maybe here's 11.2 and here is 11.4. But what does that phrase at least 11.2 mean? It means at the very smallest, it can be 11.2. So it can equal 11.2. But that's the smallest that it can be. It has to be that number or larger. On the other hand, when we have the phrase at most, that means that's the largest, the very most that can be. So it can equal 11.4, but it can't be any bigger. That's the most it can be. So all of those heights have to be smaller than that, which means we're looking at an inequality that looks like this. Now, how do we write that inequality? Well, this graph is talking about the heights of all of these action figures, and we see that it has to be in between 11.2 and 11.4. When we're talking about that h being in between, we always use less than signs. We also see that it can equal both of those endpoints, so we use less than or equal to. And that would be a good way to write that compound inequality.